Welcome to the LANDFIRE and Southwest Fire Science Network webinar. I'm Jeannie Patton, Communications Lead for the Nature Conservancy's LANDFIRE program, and this is one of a series of webinars offered in partnership with the Fire Science Exchange Network that looks at LANDFIRE's Biophysical Settings Review project. LANDFIRE has scheduled a half a dozen of these types of webinars in 2016, so please tell your friends. The schedule is posted on the Conservancy's LANDFIRE site, and we'll give you that URL at the end of this presentation. Today you'll hear from Randy Swaty, an ecologist in the Nature Conservancy's LANDFIRE team. Randy joined the TNC Michigan chapter in 2002 and the LANDFIRE program in 2007. He lives in Evanston, Illinois, and is one of the ecologists who is leading the Biophysical Settings Review and Update project. He's covering the BPS review today and will tell you what it is, how it works, and why it's important.
All right, thanks, Jeannie. Thanks, everyone, for joining in today. I see some familiar names and some new names. As Jeannie mentioned, I'm located in the Chicago area now, but spent 10 years in Flagstaff and just had the great fortune of visiting there again a couple weeks ago. So we had 30 inches of snow while I was there. It was amazing. So thanks again. And I believe Xander mentioned this, but feel free to type in any questions in the chat box as I go along. If I'm confusing you or you would like me to slow down or there's technical difficulties, let me know in the chat box and I can try to adjust on the fly. So today I'm going to go over what this thing called LANDFIRE is and tell you about these biophysical settings, models, and descriptions. We're going to talk about this upcoming review and how you can be involved. And hopefully I'll, along the way, give you some ideas on how you might benefit from using LANDFIRE data and or how it might help you in your daily work. So LANDFIRE. For our group, this name LANDFIRE is beneficial. But in a lot of ways, I wish it were land vegetation or something, because it's not just about fire. It's a multi-partner program designed to create and update vegetation, fire, and fuel characteristics for the country using a consistent science-based process. So what this kind of means is that, you know, since we have data across the country, you're not limited by your state's spatial data sets or your counties or your agencies. That's probably my favorite thing about it. As I work with different partners in the past, we always had data issues. One partner may have vegetation data. The next partner might, but they wouldn't talk to each other. So LANDFIRE tried to address this issue by working across all boundaries for the country. So LANDFIRE delivers spatial data that you're probably mostly familiar with, if you're familiar with LANDFIRE, and I'll separate that from the biophysical settings, models, and descriptions that I'll talk about in a little bit. So we use peer-reviewed scientific methods to do our mapping and modeling. We deliver almost 20 different geospatial layers and relational databases that support a wide range of analysis and modeling applications, whether fire-focused or not. And one of my favorite points about this is that you can combine these data sets. The way they were created means they play well with each other. For example, I see more and more people doing sort of coarse habitat modeling for a specific species of interest, where they will combine LANDFIRE's existing vegetation type, existing vegetation cover, and existing vegetation height, combine those in ArcMap or their favorite GIS platform, and then pull out the combinations for their particular species. So the LANDFIRE data sets play well together, and they're across the country. So I want to give you a little sort of demo of what the spatial data sets look like. Here's the LANDFIRE existing vegetation type data. And I know it's a bit maddening. There's no legend on here. It was dozens of items long, so it would be hard to view. And what I wanted to do with this first map is just give you an idea of how the data looks. You can see the patterns, and it's really fun to look at the Southwest because you see the elevational patterns, the You see sort of the desert, the Mogollon Plateau kind of jumps out at you. It's really fun to look at, if nothing else. So LANDFIRE delivers existing vegetation type. And as I mentioned, we also deliver existing vegetation cover in addition to several other current data sets. Here I did include a legend for fun. I was able to fit this on here. And I should mention these are 30-meter pixels, though that does not mean that LANDFIRE is designed to be used at a 30-meter scale. LANDFIRE is designed to be used at a landscape scale, comparing watershed to watershed or parts of a state to parts of a state. I do work with people who drill down to smaller areas, and that comes with additional review to make sure the data fits your needs and that the quality works at smaller scales. Also, more related to today's topic, LANDFIRE also delivers some historic data sets. One is this historic fire regime groups. So this sort of represents frequency and severity of fires historically, just prior to European settlement. The data for this are derived from the biophysical settings models that I'll be talking about a fair bit today. So with that, you'll get sort of a picture of what the data sets look like. And again, I encourage you to visit landfire.gov to check out the whole list of data sets that LANDFIRE delivers. Okay, so today our main topic are the biophysical settings. And they are standalone products that also link to LANDFIRE mapping. So in that fire regime group map I showed you, the data comes from the models. The succession class data that I'll talk about in a moment are represented on today's landscape by taking the rule sets from the biophysical settings models. So in other words, some of the spatial data sets rely on the models, and so the better the models, the better the maps in some cases. So that's one reason why we're doing this big review, is that we feel like we can improve the spatial data sets in some cases. So what are these things called biophysical settings? They describe how our ecosystems looked and functioned prior to major European settlement. So LANDFIRE did this to use as a reference to compare our current conditions to. Some of you may have heard of fire regime condition class. That data set, now called vegetation condition class or departure, compares current to these modeled reference descriptions. We did this, gosh, it's been a while now, and some of you may have been a part of this, by working with hundreds of experts like yourselves, oftentimes in workshop settings, but sometimes one-on-one in person or via the internet or calls to describe, model, and sort of the first draft of these descriptions. And then we solicited expert review, and then the LANDFIRE team worked through to incorporate comments and take the best of the information and put them into the models and descriptions. Then we did a largely automated QA/QC that went through all the documents in the models to make sure they matched as best we could. So we, with your help possibly, created roughly 2,000 models that were delivered in 2008. It was a massive project, and to me, it's sort of like the country's first, encyclopedia of ecosystems. And I should add, first draft. So we need to make them better, but they're an amazing resource if you haven't looked at them. It was pretty intense. We submitted 200 to 400 pages of documentations and models every 2 weeks. We were really cranking, and again, thank you if you were a part of that, because we relied on experts for a lot of the content. So when I talk about the BPSs, there's three things in a way. There's a two-part bundle, that's a text description. There's a state and transition model, and then there's the spatial data. Today I'm going to be talking about the two-part bundle, mostly. So we developed what we affectionately know as the Model Tracker database. It's sort of a monster access database that we use basically to collect information from experts. And across the top of this screen grab, you see tabs like general, classes, height, cover, and so on. The general tab collected basic information about the ecosystems. So as you see, disturbance information historically, the vegetation that would be within a particular BPS, and sort of the abiotic site factors that would guide where the mappers would place a particular BPS. So this information is fairly general. Again, it's for reference conditions. So occasionally someone would put in information about logging or invasives, but the main focus of this was historic. Also, you'll note uncharacteristic native conditions, and that's a term that I hadn't heard before I joined LANDFIRE, but that's a situation where you have native plants in a biophysical setting, but maybe the forest canopy cover is much higher than it would have been historically. Or in this example, from my part of the world in the Midwest, we have a north, central, and interior dry oak forest and woodland that is nowadays being invaded by red maple due to fire suppression. So that's noted here. Sort of to me, though, the real sort of pioneering part of this, at least at a national scale, was that each biophysical setting was broken up into succession classes. And here you see class A and B, though we went up to E. So the succession classes might also be known as seral states or developmental stages. And here, working with experts, we described what the succession class would look like, including indicator species and a text description. Then you'll notice on the right, the part that's circled, the canopy closure characteristics and the height characteristics for the succession class. Those are used to describe the reference condition, but they're also used to map succession classes today. So if, for example, our mappers map this northern dry mesic oak forest and they find canopy closure 0 to 100% and herbaceous vegetation, they'll tag it as class A. So we did not map where succession classes were historically because they moved around, but we do map them today. Greg Nowacki here did a nice job. He's got labels such as prairie, savanna. Class C is woodland. Class D is oak forest. And Class E, which you can't see, of course, would be a more mesophytic stage. So super useful. You'll also notice the landscape percentage boxes. So in Class A, we had 2%. Class B, we had 12%. Those are the expected percentages of each succession class that we think would have been on the landscape. Those numbers come directly from the modeling efforts. So that's based on disturbances and outputs from the model, which I'll show you in a moment. But I want to mention also, for those of you who are not so into fire but do more forest management, I don't know if you're kind of the light bulbs are going off in your head, but if you're familiar with Forest Stewardship Council certification, you're probably thinking about Principle 6. So this is pretty cool. It feeds right into some of the indicators for Principle 6 and FSC certification. And so anyways, there are a lot of uses for this, and I want to recognize that you know, a lot of people have done this kind of work in spots around the country. And so we definitely recognize that, and we want to bring those efforts into this national set of models and descriptions. So I'm curious, you know, how many of you people have done any sort of modeling? I know when I came out of graduate school, I had not, and I never wanted to. I thought it would just be miserable. But it's actually kind of fun. What you're seeing here is a screenshot of the software we used back then, called Vegetation Dynamics Development Tool. We've since switched over to STSIM, which is very similar. It's just a state and transition modeling where each box represents the succession classes, and you'll see within the box you have numbers that represent the years that that succession class would occur. Some sort of generic labels such as open or closed for a canopy structure. And then you'll see early, mid, and late. That just helps us keep track of what's going on. So within each one of those boxes is the cool part. That's where we enter in the disturbances and what they might mean. So for example, if you had a replacement fire in Class C, it would send those acres back to Class A. So we would state that while we parameterize the model, and then we would say how often that happens. So in this particular model, much like in the ponderosa pines out west, you would have modeled in here fairly frequent surface fire with much rarer replacement fires. So these oak models work a lot like your ponderosa pines do in a way. So we would run the model to get those landscape percentages. And with that, I'm going to break for just a second and check the chat box, and wonder if you have any questions before I move on. Well, at the moment,
it's going well. You don't have any questions yet.
All right, or everyone's eating lunch or taking a nap, which I see it's about that time in your part of the world. So understood. So I'm going to plug away, but keep those questions ready if you have them. So I'm happy to discuss as we go along. So to run the model, we did this. We ran each model for 10 times for 1,000 cells for 1,000 years. So we weren't modeling 1,000 years into the future or anything like that. We were just running the model for a long time so that the disturbances could equilibrate, and so that when we got our succession class percentages, we felt that they were pretty solid. And you'll see a graph of that below. So we started with equal percentages in each succession class at time step 0, then we just let the model run for 1,000 years. Of course, if you're going to model running into the future, you would try to get, you would quantify how much of each succession class you have on the landscape today, and probably wouldn't run the model for 1,000 years. But this was almost a sampling exercise. We wanted to run the model for a long time so things could stabilize. All right, so once we ran the models and put all the information in that model tracker database, we contacted people similar to like we're doing now. We tried to get review and tried to get input. And as you might imagine, some ecosystems had a lot more review than others. At the time, I was in the Great Lakes, and our Great Lakes alvar ecosystems, while they're super important to some people, are not that well known compared to the northern hardwoods. And I suspect you guys have the same thing where, you're flooded with information on ponderosa pine, but maybe some of your alpine ecosystems aren't as well known. So we did the best we could, but we know that the models can be improved. After years of use, we're finding issues, and we want to try to fix as many as we can. So I see a question from Tim, and thanks, Xander, for following up. I'm not exactly sure what you mean there, Tim, but if you can give me a little more information, I'll try to clarify if I need to. So we delivered, as I mentioned, the descriptions in the model bundles every 2 weeks, and these models and descriptions were the first cog in the machine of the biophysical settings, the succession class, and that vegetation departure data set. So they're really important for the spatial mapping, and people have been using them around the country for all sorts of planning and research questions. For example, here are some papers I pulled out for the Southwest. If you go to Google Scholar and you were to put in LANDFIRE and Southwest or some states, you get tons of papers. And so people are doing research, conservation planning. For example, in Nevada, they have done a fair amount of modeling where they take the LANDFIRE reference condition models, they bring them up to the current situation, so throwing in grazing or exotics or logging. Then they model into the future under different management regimes. So the LANDFIRE model serves sort of as a springboard for other work. Also, as I mentioned, sort of in the spirit of forest management, people are using these biophysical settings descriptions and models for ecological assessment, where you compare the reference models to your current situation. And that may or may not, depending on your values and your goals and objectives, help you decide where to go in the future with your management. Okay, as I mentioned, we know these models and the descriptions are not perfect. We are finding there's just blunders, typos, and inconsistencies, for example. We know there's new science, we know there's new opportunities, and we're hoping to have an upgraded delivery system. Right now, if you go to landfire.gov and drill into the vegetation button and into the biophysical settings, you can download a monster database with all the information for the whole country, or PDF files for what we call our map zones. So they work, but we would like to make it a little easier for you guys to get the information. And also, as I mentioned, we have STSIM available now, which is a much more modern state and transition modeling platform. So in general, we know that we can make things better, and we need your help. I'll be scouring literature for my part of the world and the models I'm responsible for, but we want to work with people like you because we just can't keep up with all the science on all the ecosystems. So we really feel like you guys are key to helping us make these models better. So we have done a fair amount of work to get ready for this already. We did what we call cleaning the biophysical settings list. For example, we may have had, numerous ponderosa pine models that were extremely similar, if not similar. So if that were the case, we would review and lump those. We may end up teasing some of them back out after review, but we needed to clean things up to understand where we were. I know in my part of the world, I had northern hardwoods models that were identical across multiple areas. And I need to split those out and make them more customized for Wisconsin or Massachusetts. And you see here we have landfirereview.org. We hope it's simple for you. We hope it's easy to use. You can go there, and our contact information is there and instructions on how to download Word document descriptions of all the biophysical settings and do your review. We hope it's simple and enjoyable for you. I know it sounds kind of weird, but maybe it'll be fun for you to take 20, 30 minutes and just think about ecology of your favorite ecosystem for a while and throw in some comments into a Word document for us. We hope that's the case. We're also, we have laptops, we'll travel. We're willing to try to meet with you in person if that's what you prefer, or if there are bigger issues. For example, we may need to look at ponderosa pine from north down into Mexico and do more of a regional look to make sure that we represent ponderosa pine from place to place to place properly. That is, taking all the models and descriptions in context. So we may need to have some sort of a meeting to do that. Okay, Eric has a really great question, and it's one that it's been really important for folks in the East and for you guys as well. For our biophysical settings, soils are used to map where those biophysical settings are. but we do not have succession classes lined up with particular soil types. So it's sort of at the first level, soils are very important, but not for those succession classes. And that's an interesting question, especially with climate change, nutrient cycling changing. And you know, yeah, thanks for that question, Eric. Because I'm now thinking, gosh, you know, where we have red maple invading our oak ecosystems, for example, it's changing the soil. It's changing things a lot. So, if we were to be modeling into the future, that would be very important. But for the reference condition, we do not have soils changing the trajectory. And yeah. So I want to make it clear that we're kind of modeling the past, understanding that the future is going to look a lot different. So I may have confused things a little bit there with my comment looking at the chat box, but soils are important to map where biophysical settings are, but they do not factor into the modeling of where succession classes are or the relative amount of succession classes. All right, and with that, Jeannie is going to jump in and tell you how to get in touch with us, and then I have time and would love to talk with you if you have questions, if I've been confusing, or if you have ideas, or anything else you want to talk about.
Hi, this will be a quick one, mainly reading what you've got on your screen. Most of you know where the LANDFIRE program home is, landfire.gov. The Conservation Gateway is the Nature Conservancy's site where LANDFIRE lives. We try to keep that up to date, especially in terms of our library, and welcome any of your contributions and reviews. Our Twitter feed's very active right now, nature_landfire. We do have a YouTube channel. I mentioned earlier that we'll be posting this recording, and others are already up in our sections there that include understanding LANDFIRE, and we are also developing a series of BPS review tutorial videos that are about to be posted. We send out a bi-monthly bulletin and postcards as needed when we have news to announce. You need to opt in to receive these. There's the URL there. Probably easier to send me an email at landfire@tnc.org. If you'd like to get the bulletin, I'll send you the opt-in URL and links to all the bulletins from 2015. They're online now, so you can catch up with us. But you do need to opt in. And then, of course, all our mail can go to landfire@tnc.org. I'm monitoring that, and that's also where you'll be submitting your BPS review documents. And one more time, there's the review website. It's easy, landfirereview.org. And we welcome any and all correspondence. Thanks.
Thanks, Jeannie. And thanks, Michelle, for a great question. At the moment, I do not know of any universal LANDFIRE plans to model into the future. We work with landscapes a fair bit to help the landscapes do that. But as far as a countrywide effort, I do not know of any plans to model into the future. Any other questions? Great question, Amanda. Yes, so my favorite example I just vaguely alluded to earlier was in Nevada. So our colleague there, Louis Provencher, has worked with multi-stakeholder groups to examine best ways to get to a desired future condition. And it's really pretty amazing what he's been able to do. And we have a colleague, Greg Lowe, who's done similar things with our Nature Conservancy partners in Tennessee. So what happens is you get multiple stakeholders together, and there's always issues, right? You know, you may have, you just have everybody's groups with everybody's values. And by going into modeling using LANDFIRE or other models, you can take sort of a collaborative learning approach where the models and the data set become more of the issue than possibly disagreements on what to do. So what we like to do is take the LANDFIRE models as a base and then throw in all the current expertise. Again, for a landscape, we're not doing this for the whole country, and model out what would happen if we were to take one management regime versus another, versus another, versus another. And also what we can do is start to, throw in cost so that we get almost a return on investment estimate. So if you go into the Conservation Gateway and type in landscape conservation forecast, you'll get some great resources for that. And in New Mexico or Nevada, it's resulted in, a litigation-free NEPA plan, which was amazing in a place where that hadn't happened before. And then the Cherokee National Forest, they were able to come to guidance for the forest, the partnership group, and break kind of a stalemate of 10 years. So models to the rescue, which is really weird. You wouldn't think that, but again, it's a documented approach called collaborative learning, and you can Google that as well. The other thing that we've done using LANDFIRE in more of a forest management way is to explore how a particular management unit fits in the broader landscape. For example, the Nature Conservancy does some harvesting, and in the Upper Peninsula of Michigan, for example, and in other places, we will look at the large landscape and basically assess what can we contribute to the landscape that maybe our other partners can't. For example, our partners may need to focus on fiber production for paper, and so they really can't focus on forests with old growth characteristics, whereas we can. And then that jumps out at you when you look at broad scale data such as LANDFIRE. Okay, and Eric has a good question. So that's a really great question. So in our biophysical settings descriptions, oftentimes the modelers will describe what climate parameters might guide where a biophysical setting would have been historically. And obviously, we didn't always have pre-settlement climate data. So it's very difficult, but we went back, and I don't remember the years, but we went back several decades and developed several input grids of climate to help us map out where the biophysical settings would be. So it's using the sort of the best combination of descriptions of what climate might guide where a biophysical setting would be, and that going back as far as we could to actually get that climate data. But again, mapping where these ecosystems were historically was largely based on slope, elevation, aspect, soils, superficial geology, and to some degree climate. Okay, and Amanda has a really good question too. I don't remember the scale of that application in Nevada, honestly. Excuse me. I know that we start getting nervous if someone uses the spatial data. I'll throw out 100,000 acres. It's hard to do because every landscape's different. So it's really designed for large landscapes. That said, I've worked with partners, and we would drill down to much smaller areas, but that was after we really understood the strengths and weaknesses of the data. The descriptions and the models are not quite as scale dependent. You can get a picture of what an ecosystem would look like from those descriptions and use it more in a qualitative way that's not as scale dependent. So if you guys, when you look at the models, what I do for my part of the world is I'll look at the authors, not to pick on the authors so much, but some of the models were just written by people who are leaders in a particular ecosystem. And some people like me would write models and do the best they could, but they're not leaders. So there's some models with my name on them, and your confidence-ometer goes down when you see that. Then I look at the references section, and that gives some information. And honestly, I'm just poking around. You can't see that I'm doing this, but there is a checkbox for local data. So long answer, Tim. Sorry for this, but that's interesting. I could probably look into this database and probably get an idea of how many experts checked that they used local data. So yeah, good question, Tim, and we should probably make that more explicit and make it easier for experts to kind of either give local data or say that they didn't have local data or highlight that we need more data, something like that. So great questions. Thank you so much. I'm going to mention one more thing is that Corey Blankenship, my counterpart in Bend, Oregon, and others have worked out a method for actually having ranges. So right now, we just have a % for the succession classes. So succession class A might be modeled to have 12%, succession class B 42%, succession class D 50%, and so on. But managers need more flexibility, and we all know that across a landscape there's variability. So she has worked out a way to actually give robust ranges for those succession classes. And that information is also on the Conservation Gateway. And it's not too bad of a process, but you do need multiple sources of information for the disturbances to do that. Well, I hope you guys will contact us and go to landfirereview.org and poke around. Honestly, we've heard it all through the years. You're not going to hurt our feelings. So if you tell us, the website's junk, I can't figure out how to get those Word documents, that's helpful to us. Whatever, we're open for feedback on the process and on the biophysical settings. We're going to do our best to incorporate your input. So we really hope that you'll check it out and let us know what you think.
Randy, this is Xander. Thanks for a great presentation. And if there are no other questions, I think we can wrap up today's webinar. Great. Well, thanks to everybody for participating. And you'll get an email from the Southwest Fire Science Consortium with some of these links and notification about the recording in case you want to share it with a colleague. So thank you all, and look forward to seeing you on future webinars.